Okay, so what we're going to do today is we're going to go over the Linux fundamentals again, so how we connect to the system, how we use a couple different commands to do the things that we want to do, things like that. Then we're going to review a basic C program, remind you of some of the functionality that we can utilize in a basic C program, how to compile it, how to do things like that. We're going to talk a little bit more about what that include stdio does at the top of the program. Talk a little bit more about what data types we can expect to see in this class, talk about printf, and then finally work on an in-class assignment to kind of get you acquainted with printf a little bit more. So, to get started, any questions or concerns at this point? All right. So again, this is our basic C program. So at this point, what you really need to know is that lines 1 through 3 are pretty much just required. You just need to use them. There's lines 4 and 7 which have an opening curly bracket and a closing curly bracket. And inside those curly brackets you can put any number of statements. So a statement just being defined as something like this. This is the printf statement. So we say printf, we say opening parenthesis, closing parenthesis, and inside that printf we put in quotations the string that we want printed to the terminal. Now in order to finish off that statement, we put a semicolon at the end of the line, and that's true for all statements. So every single statement that we write in C needs to have a semicolon at the end of the line. Now one thing that isn't required is this indentation here. I think you see the mouse, yeah. So there's this indentation here between, so this would be 0 indentation if the line started here, and this would be any number of indentation right here. That indentation isn't required, but I generally like to see that indentation so I can see exactly what statements are running inside that block. Later on, what we'll do is we'll put blocks inside of other blocks, so indentation becomes very important to understanding how the program's functioning and things like that. So this is going to be a little bit different than what you have. I'm on a Mac right now, so I'm connecting to the system a little bit differently, but just follow along as it was before. If you do have any problems connecting or doing things like that, I did post this connecting and Linux fundamentals in week 2 of the content section. So if you don't remember how to connect or do anything like that, just head on over there, open up that document, and it will show you exactly how to connect, what your username should be, how to change your password, things like that. And it'll tell you about a bunch of different commands that you can use on the system to edit files, create directories, things like that. I'll talk a little bit about the nano editor, how to use GCC, how to verify that GCC is actually outputting something, and how to use the submit command to submit your programs on the box, and the structure of a basic program. So if you forget any of those basic things, just head on over to week 2 and take a look at that document. So going back to our basic program. So remember on Tuesday we looked at hello.c. So if I open that up again. So remember, like I was saying, if we want to put more statements inside this block, we can do that. That's completely possible. So let's say I want to add to this, and I want to print out some more stuff. Let's say I just want to print, let's say 1 or something like that. We just put another statement. Remember, we say printf, and then we need, this is the very basic printf. This is going to print absolutely nothing, but this is at the very minimum what you need to be able to do a printf. And then you put whatever data you actually want printed to the screen inside that printf. I actually forgot this here. Let's continue on. So we can put as many statements as we want. We can separate them by as many new lines as we want, so we can have a bunch of different lines in between there. Spacing isn't really an issue, so you can format things however you want to. So going back, we can compile that program. Remember to Control X, press Y, and then hit Enter to save your changes and everything. And then say gcc hello.c. And I messed up a couple things here. So we can see that I missed my closing quotation over here. So going back over here, I need to put a quotation mark. So all the content that we want printf to output to the screen needs to be inside these parentheses and inside these double quotation marks. So we'll talk more about what those double quotation marks actually signify a little bit later today. So going back, we need to save that. So it's also worth noting that when we're compiling our code, there's a couple different things that can be outputted. So the first thing that can be outputted is a warning. So what a warning means is that the compiler detected something that isn't correct. The syntax that you, or the characters that you typed in, that you saved in your file, your source file, aren't exactly in line with what they should be. And but the compiler can just go around that and it can make it work anyway. However, when there's an error, that means that your program will not compile and it will not generate a new executable. So, looking at that, so I'm going to, here's the files in my directory, I'm going to delete the hello executable. And then I'm going to compile it. And then look at the directory again, so it's not there. So in order to get that executable, we need to compile it. So we say hello. Remember, we can use the -o to rename the executable that's generated by GCC. So we can say hello like that. And since there's just a warning that's outputted, that code is still generated. But if there was something more severe, like we go back here, and we forget to put this closing quotation like right there, delete the executable again, and generate it again, we can see that there was errors and there was no executable generated. So a lot of times what will happen is you'll write your program, you'll make some changes, and you will try and compile it again. And since you compiled it good before and the executable was still in your directory, you see it again and you think the program's changed. But if in the output from your compiler you have errors, and sometimes if you have warnings, your program won't run as you intended. So that's good knowledge to keep in mind when you're writing programs. It simplifies a lot of issues that people have later on. So going back here, remember, in order to make this right, we need to put a double quotation mark there. So I just opened this in another editor. So there's multiple editors that you can use on the Linux system to edit your code. The one that we talked about was Nano. And for the most part, that's easiest for beginners because it's the most like other editors that you've used before. But every so often, I'll accidentally or not accidentally open Vim because it's the editor that I am most familiar with. So just some basics about Vim if you're interested in it at all. So in Vim, there's a navigation mode and there's a command mode. So don't open it up right now. I'm just going to kind of describe the things. If you did open it up, yell at me and I'll try and describe how you'd get out of it. That's the biggest issue that people have with the Vim editor when they're using it is, yeah? All right, we'll go over it. But that's the biggest issue that people have with the Vim editor is actually getting out of it. So anyway, so the notion of command mode and navigation mode. So right now, I'm navigating around this editor with the J and K keys. So it's kind of based around the notion that you don't want to take when you're typing, you want to keep your hands on the home row, and you never want to go down to the arrow keys to move and everything. So you can see my cursor's moving around like that. Now, in order to switch from command mode to insert mode, or a mode where you can type, I would have to like press O, which would create a new line, and I'd start typing on the next line. Or I could do something like this. I could push capital A, and it would start typing at the end of the line, and a bunch of different things like that. In order to get out of insert mode and go back to command mode, you'd push escape. And in order to exit from Vim, you'd say :Q. If you've made any changes, you either need to write the changes by saying :WQ, or just saying Q exclamation point, which will exit Vim and discard all the changes you've made to the file. So if you're interested in Vim or in kind of a more interesting editing approach. It's certainly something worth looking into. If you spend the time learning Vim now and you're interested in computers going forward from this point, it's definitely worth the investment to try and learn the Vim editor as soon as possible. Some people never like it. I know graduate students that don't use it at all because they just hate the ideas and principles it kind of stands for, but it's certainly an interesting editor at the very least. So, going back to our program, there's actually one more component that we need to make this a valid good-formed program, and that is to say return 0 at the end. So you notice that when we were compiling this program before, we were having, we are having this warning right here, and that says, warning, control reaches end of non-void function. And we'll talk more about functions later, but what we need to do right now is just say return 0 at the end of our main function. Basically what this does, when we say return 0, that notifies the system that we successfully ran our program and did not encounter any errors. Later on, we'll talk about we could return other numbers from main. If we encountered an error or something like that, we could say return -1 if we encountered an error or something. But for now, since our logic is fairly straightforward and we aren't really going to check for any errors or anything like that, all we want to really do is say return 0 for right now. So if we close that program again and compile it, so when we're at the command line, here's an interesting thing that you can do. So as of right now, you'd have to retype every single command, but you can actually push the up and down arrow keys to navigate through your command history. Just stretching. Okay. So press the up and down keys to navigate through your command history. So let's just say we want to navigate up to where we compiled our program. We could do that. And then, in order to run the executable that was generated, we need to say /hello. And since we modified that program, instead of just printing hello world, my name is, in my case, Alex, it's also going to print 1, 2, and 3. So opening that back up, we can see that that is the case because we have added multiple printf statements to accomplish those additional commands. Again, white space isn't really significant. You could have your program formatted like this. You could have it formatted like this. You could have it formatted in a bunch of different ways. But again, generally speaking, it's nice to, when you are in between these brackets, when you're inside a certain level of brackets, what it's good to do is just hit the tab key and then start typing your line. And we'll talk more about that later. But that's the basics of a C program. So talking a little bit more about this line right here, this include stdio.h. So when we say this include stdio.h, what that allows us to do is use this printf command to output things to the terminal. If we weren't to say include stdio.h, let's just take that out really quick and see what happens. It should give us a warning. So it says, warning, implicit declaration of function printf. And this isn't something that's really that bad, but it's just, at this point, it's good practice to say include stdio.h at the top of your program. And again, what that allows us to do is it instructs the compiler that we are going to be using the printf command or function inside our program somewhere, and that it should understand what we are trying to do. There's a bunch of different other header files that we'll look at later. So as we go on, our program might say include stdio.h. Might say include stdlib.h. Might say include time.h. Might have a bunch of other different things. And when we say include a header, or when we issue those directives, which instructs the compiler to look at that header file and determine which functions, commands we're able to use, there'll be a bunch more available in stdlib in time that we don't have available specifically to us in stdio. And basically what stdio does, the actual commands and functions that it contains are input and output functions. So functions that can write to the terminal and functions that can read from the terminal. And later on in a 250 class, you'd learn that it also contains functions to read from files and write to files as well. So that's about stdio. So going back over here, we could look at the Linux fundamentals again a little bit, I guess. So remember that there's the ls command to show the files in the current directory. There is also other options that we can give to ls to specify a little bit more detail. So we can say lsl, and that will list who owns the file right here, when the file was created right here, and its size right here. So this is its size in bytes. To get a little bit more human readable view, you would say ls-l and then say ls-l-h, and that stands for human readable. So that means it's going to take this number and it's going to convert it into a format that we can read more easily. So instead of saying 6,760 bytes, it's going to convert that to kilobytes, so it's going to say 6.7 kilobytes. And that's how big the executable, in this case, that we are generating when we're saying gcc hello.c is. And that's kind of worth knowing sometimes, but just kind of also good knowledge to have. So normally when we open a file up with like Nano or something and the file doesn't exist, Nano is just going to create it. The same is going to happen with any other editor we use. So let's say nano my file, open that up, and then exit out immediately. It's actually not going to do anything. So if we type something in, let's just put ASDF in there, we can see that Nano created that file. We can again delete the files by saying rm and then space the file name that you want to delete. Or if we want to create a file without doing any other thing, we can just say touch. So we say touch my file. And that will create it without opening up an editor or anything like that. So we have the mkdir command to make a directory. So what I said on Tuesday was it'd be really great if you could make directories for like your daily assignments, for your assignments, and for practice, just so you could keep things sorted out. So let's say we want to make a directory for practice. Looking at our ls output, we can see that that is a folder, since it's blue. And we can see into cd into that folder. So that's going to enter that directory, and we look at that. And since we just created that directory, it's going to be completely empty. So if we wanted to go back to our home directory, the directory that we were originally in, we can just say cd, and that will return to our original directory. If we want to delete the directory that we made, we say rmdir practice. So that will delete the directory. So let's make it again here. There is one thing that we have to keep in mind when we are making, or when we're deleting directories, I should say. So let's say I touch, so I create the file, my file. So I just didn't spell that wrong, right? I'll just remove it. So I'll say touch my file. And now we have a file inside that directory. So let's say we go back up and we say rmdir practice. We're actually going to get an error, and it's going to say failed to remove practice directory not empty. So in that case, what we actually need to do is we need to use the rm-rf command if we wanted to delete the entire directory. So we'd say rm space, that's not rm, that's rf. We need to say rm space and then rf and then say practice. And that will delete all of the files inside the directory. If there's a directory inside a directory, it'll enter the directory inside the directory and delete all the files inside that, and so on and so forth. But basically what we have to do is we have to manually delete each file inside of a directory before we delete the directory itself. So that's what that command does. Another hint that you might care to know is you can actually press Control R, and it will open a prompt like this. It'll say reverse I search. So let's say we want to go back to our GCC command way back when. Instead of pushing up until we get back up to the GCC command, we can actually just say Control R, and then we can say GCC. And it will search through our entire command history, and it will find when the last occurrence of us typing GCC was, and it will put that on the command prompt. Now we can either push Enter to execute it right away, the command that is, or we can push the arrow keys left and right to modify the prompt and change what it is. So that's a good way to go back to other commands that are kind of far back that we wouldn't necessarily want to just keep pushing the up key to get back to. So just another hint, isn't necessarily required that you remember it, but it's definitely going to speed things up in the future. So we're going to make a directory again. I'm going to accomplish that by searching for it. So mkdir. I'm going to enter that directory. What was I going to do? So I said before that you can just type cd to return to your return to the home directory or your original directory that you get when you log in. You can also do this. You can cd ... And what the ... stands for is change directory to the directory above the current directory that you're in. So let's say we have another folder inside our practice directory. Let's just make, or directory, sorry, make dir. We'll cd into dir. We can see that, remember that the tilde stands for our home directory, and then there's a practice directory underneath that, and a dir directory underneath the practice directory. So let's say we wanted to go back to the practice directory, but we didn't want to go back to the home directory itself. We could say cd ... and that will go up one directory. So we can go back into dir by saying cd dir. And if we wanted to go up two directories, we could say something like this. We could say cd ... which stands for, again, the directory above our current directory, and then slash ... which is the directory above our current directory. And you can continue these on. You can go as deep or as shallow as you want to. It's all up to you. So again, when we're saying / and we're running our command, so hello, what that stands for is in the current directory /, so dot is the current directory / hello. So it's looking at our current directory and is going to execute the hello command. So if we were to change our GCC, we were to say GCC, and remove the O, the -O hello, list the directory again. So remember that without saying -O and specifying the executable name, we are going to always generate a.out by default. So again, when we want to run our command, we can see that these green items in the file system from our ls command are executables, and we can execute them. So we can say /a.out, and then we'll execute our program. And again, you can remove things by saying rm. That's pretty much, there's one more thing. So there's one concept that's kind of difficult to understand at first. So let's say we have a file called myfile. So in Linux, there's not any rename command. What you have to do is move the file from the old file name to the new file name. So think of it like this. Think of move as being the same as rename. So if there was a rename command, it would be exactly the same as the move command. So in order to rename a file, or in this case move it, or something like that, you would say move, or mv, and then the old file name and the new file name. So it's going to move my file, and it's going to change it to be this name. So let's say you started off making a C program. I'll call it my program. So this is the very, well, I guess I don't even need this. So this is a very basic C program. This is the very minimum you need to have a C program. It doesn't actually do anything, but it's a completely valid program. However, GCC says file format not recognized. So what that means is that you did not put the .c extension at the end of your file. So let's say we wanted to take the code that we've already written in my file and we wanted to just add the .c extension. So what we need to say is mv my underscore program, and we need to say my underscore program .c. And again, you notice that I had typed, like, I typed about this much, so I'd gone my underscore p, and then I hit the tab key, and again, that expands out the rest of the program name as it's detected on the file system. So in order to rename that file, my underscore program, you need to say my underscore mv my underscore program, and then say my underscore program .c. So now we can use GCC to compile that program. And again, we have that warning control reaches end of non-void function because we did not put the return 0 at the end of our main function. We can go back and do that really quick. Again, it's kind of optional at this point. I'll expect it later on, but just so you don't get errors, you should say return 0 at the end of the function. So that's all I had for Linux fundamentals and the commands that you can run. Again, if you're more interested in any of those topics, do look online, try and find some more interesting command combinations. Any questions about that? Anybody stuck anywhere? Is everybody on the same page, kind of? All right. So we talked about this. There's a couple different header files that define different functions that do different things. So there's the printf function, which outputs this to the screen. And there's the puts function, which does almost the exact same thing, but it automatically prints a new line. So that's, again, a \n, which takes the cursor and moves it down from the current line to the next line automatically. So let's go over here and look at those two functions really quick. So the two different ways you could print off something. Again, we need to include stdio.io.h, and we need to say printf hello. And in order to take the cursor and move it down to the next line, we need to say \n. Otherwise, we could use the puts command or function and just say hello. And these two are completely equivalent. The printf command is much more powerful, and we'll learn more about why we want to generally use printf later on. But just keep in mind that there's multiple commands you can execute that are contained in stdio, and these are two of them. So those are identical. So let's say another header file, math.h, contains certain math commands to, let's say, calculate the sign of a number or calculate, let's say, 2 to the 10th power. We'll, again, spend more time later on in the semester looking at those, but just so you kind of know where we're going. So looking at a couple different kinds of data that we'll see in this class. So the first that we've seen when we're outputting hello world is a string. So a string is indicated by a number of characters inside double quotation marks. So it would be double quote, I love programming, and then an end double quote. So in order to have a string, again, you could have a string with a single character if you wanted to. You could do something like this. You could just have a single H or something like that. But the whole point of a string, see it printed this single H here. The whole point of a string is it has the option to be 0 or more characters inside the double quotation marks. So when we're using printf, when we're using a function like that, it expects that there is going to be a string inside of the parentheses right here. So different commands expect different things. Like we said before, there's other functions that we can use later on. So a function like sign or power would expect numbers to be provided inside the parentheses, but printf and puts only expect or at this point, only expect a string. So there's also single characters. So we can say a single character, one single character, not a group of characters. Again, a group of characters is a string, but a single character is just like this, a letter inside double quotation marks, or any single symbol that you can type on a keyboard inside single quotation marks. So then there's also integers. So those are whole numbers. They can be positive, they can be negative. There's no quotation marks around them. And there can be floating point numbers, which are numbers that have a whole number component and have a decimal component. So in order to get started working with these, we're going to look at how we can use printf to output these different kinds of numbers. So when we're using printf, we can actually write something called a format string to take this data and output it to the terminal in a very standard way. So looking at this, there's a couple different kinds of format identifiers, as we would call them, inside our printf command. And what that does is, so we specify a format string here as our first argument, we would say, to the printf function, and then we would place commas between the rest of the arguments to the function. Now what's going to happen here is it's going to, or printf, we're going to specify that a string is the second argument to the printf function. And what it's going to do is going to take this data right here, which when we say the second argument to the function, we mean the second thing after the comma. So right here is the first argument, and then we have a comma, and then we have the second argument right here, and then we have a comma, and we have the third argument here, comma, fourth argument, fifth argument. So when we say in the first argument, %s, it's going to look ahead to the first, or I should say the second argument. It's going to take this data right here, this hello, and it's going to essentially substitute that hello for this %s. Now, we say %s because the second argument to the printf function is a string, and we need to instruct printf that the data that it's going to see is going to be a string. So we go here and we look at the third argument is going to be a character A. So in order to print that off, we need to use %c. What that's going to do is it's going to look at the third argument right here. It's going to take that character and it's going to replace it right here. The third thing we're going to see in our format string is the %i. That means that we're going to look for an integer in the third position of our printf, and it's going to replace that 5 for that %i. And then finally we have a %f, and it's going to take and it's going to replace that %f with this 10.1. So going over to our program, I can start it off a little bit easier than that and say printf %i. We're going to say %i and then /n for a new line, and then we're just going to say 10. So again, what this is going to do is it's going to, since printf sees this %i inside of the format string, it's going to look to the second argument right here, and it's going to grab this 10 and it's going to put it in the place of the %i. So going back, we're going to GCC. And then run that program. And then that program is going to print out 10. However, let's go back and look at this. So if we were to say, let's say %c instead of %i, and recompile the program and run it again, we're not going to get exactly what we expect. So we need to make sure that when we're specifying data, like we want this 10 to be printed, because that's an integer, we need to say %i to print it as an integer. If this was a character, if it was like character C, or let's make it B, we need to use %c. So looking at that, that prints a B. But again, if we were to use the wrong format identifier, if we were to say %i and we were trying to print out that B, that would not work. That would print 66. And we'll talk about why it's printing 66 later, but for now, just make sure that you're using the correct format identifier. So if there's no format identifiers, you don't need to specify anything after you don't need to separate any of the further arguments to the function by commas. You can just say ASDF. But if there's a format identifier in here, so a %I, a %C for character, S for string, F for floating point, it needs to see what you want to print out afterwards, after the format string separated by commas. So do something like that. If we wanted to print out something further, like a floating point decimal number, so this I again is going to be replaced by this 10 here, and then let's print out 25.25. This %F is going to be replaced by the 2525. So remember that numbers don't have quotation marks around them. Strings, which are multiple characters, have double quotation marks around them, and single characters have single quotes around them. So looking at that, we can see that that program outputs something close to what we were thinking about. Not quite what we wanted, but we'll talk more about why it's printing out like that later. But we get the general picture. So, what time do we have here? So just keep this in mind, what these format identifiers are. Again, if there's, you could have multiple single integers. You could have all of one type. You could have none of one type. That's completely up to you. So let's just change it around here. If we wanted to print 1025, we could do something like this. If we wanted to format that like a time or something, we could say 10:25 p.m. It prints nice like that. So the whole point of printf is to take the data that's stored by the computer and print it out to the console or terminal in a way that can be read by you, the user of the program, and by the developer too. So we have noticed already that we can say \n to print a new line in our code. So I'll just delete all this really quick. So we can say just a /n, and that will only print a new line. So just one blank line. We can have multiple new lines inside of our printfs too. We can say /n/n/n. We can say as many new lines as we want to. And it gets a bunch of blank space. And we can put anything in between those new lines or do anything we want to. And we can put those new lines anywhere inside our program. So we can say A, S, D, F. And after every single character, it will take the cursor and it will move it down a line. So that's what the /n's do. So there's also a couple other ones that we can use. There's also a /t, which is a tab. So let's say we wanted to space out things a little bit. We could put a /t before every single character. And that will tab everything out one tab width. So tabs are really important later on when you're trying to align your program output well. So just keep in mind that you can use /t to align things. And it's also worth noting, let's see, I think I can do this. That tabs align to certain spots on the terminal. Let's say I think it's every 8 characters it looks like. So if you have content and you want to align things further on, let's say make a table or something, you can use the /t to align things. So that's all I have for you today, but I do have an in-class assignment that I'd like you to work on for the rest of class. So what I'd like you to do is create a C program which prints out a string, a character, an integer, and a floating point number. Build a format string using the format specifiers or conversion specifiers below, and then submit it to day 3 in class. Now there's really two ways you could go about doing this. You could build the format string like I had said before. You could build it almost exactly like this, where it's entirely in one format string like that. Or what you could do is you could do something like this. You could say printf %i for an integer, and then specify your integer. And then use another printf, if this is a little bit easier maybe, for your next type, and do things like that. But regardless, when you log on to dev.dsunix, and so do submit-l, of course I mess something up again and you won't see any assignments. But let me go back in here. It is not Wednesday today, it's Thursday in fact. That's why. So let me just edit this assignment really quick. And I just went past it. One more time, I'll get it this time. It's the 22nd today. Oh, it is the 21st. My dates must be off. Oh, that's why it's 20. It's not 2015. It's 2016. So, got to get on the right page. And now you should be able to see your assignment. So, go through, do that, make the C program which outputs each type of data once. That's all you need to do for today. By all means, ask me any questions if you have any questions about this assignment or any other assignments or other problems you're having with this class. So that's it. I will bring that back up here right after I